This video is about the instant graphs, the graphs which you really must know off by heart. And I'm often saying that you need to know not only the general shapes but some key points that they go through. That's because when you transform these graphs, it's advisable to move the points rather than the graph as a whole, and then once you move the points, then you connect those points to reconstruct the graph in its new location or its new form. So now, what are the instant graphs? Well, first of all, there's vertical lines. X equals 3, for example, is that one there. What else have we got? Y equals 2. If it's y equals something, it's a horizontal line. So, for example, y equals 2 there. Okay, so these are some exceptions to the principle I just stated, which is you need to know some key points it goes through. Here, because they're so special and so simple, just one point will do. The y-intercept for a horizontal line and the x-intercept for a vertical line. Next instant graph, y equals x. You need to know that it's a 45-degree line and it goes through these three key points. 1, 1, 0, 0 and -1, -1. Also through those key points is the basic cubic or snake shape. Goes through the same key points, and try your best to make it look flat when it's going through the central 0, 0 origin point. So what I've done there is y equals x cubed. So that's 4 instant graphs so far, this one, this one, this one and this one. What else have we got? We've got y equals x squared. That has 5 key points. Goes through 2, 4, 1, 1, 0, 0. It's never hard to remember these. If y was equal to x squared, then the y coordinate is what you get when you square the x coordinate. So it's no surprise that that's 4, because 4 is 2 squared. This is -1, -1, and this is -2, 4. So that leads to the classic parabola shape. So that's another instant graph. What else have we got? Y equals square root of x. This goes through 3 key points. 0, 0, 1, 1 and 4, 2. Easy to remember those because the y coordinate is always just the square root of the x coordinate, but you must remember that this graph just suddenly leaps out from the center. Sorry, that's sloppy there. And it continues on going forever to the right hand side. It goes up forever. There's no y coordinate this can't get to, even though it looks like it's bottoming out. Sorry, not getting quite as steep. If you go out far enough to the right, you can get to whatever y coordinate you desire. Y equals 1 over x has 6 key points. 1, 1 and -1, -1. For the sake of neatness, note you don't always have to draw on these coordinates. It also goes through 2, half. So half, 2 and 2, half. It also goes through -2, -half and -half, -2. And crucially it has asymptotes, which you must draw very carefully to make it look like they're getting ever so close to the axes but never quite touching it. The lines that it's getting close to but never quite touching are called the asymptotes. This curve, by the way, is called a hyperbola. It's actually referred to in Thomas Hardy's Far from the Madding Crowd. He needs to come up with an analogy about getting closer to something but never quite reaching it, and he uses a hyperbola to make that point. Now, what else have we got that has asymptotes? We have the exponential graphs. The exponential graphs always go through 0, 1. So, for example, I'll draw y equals 2x in black, and y equals 3x in red, and I'll also actually do y equals half x. So I'll do, that in blue. Okay, so all 3 of them go through 0, 1. Okay, all three of them also go through whatever this number is when you're at an x-coordinate of 1. So, up at 3, we have this one. Out at 1 we have this for half. And out at 1 we have a y-coordinate of 2 for the black one. And so basically it's always 1 at the centre, 1 out to the right, it's whatever this number is, whether it's half 2 or 3, half 2 or 3. And over to the left, an x-coordinate of -1, it is the reciprocal of these three numbers, because that's what a negative power does. So reciprocal of that is 2. The reciprocal of this is a third. And the reciprocal of that is a half. So we're now ready to draw them. I'll do the black one first. Doing my best to make this look like an asymptote here. This gets up incredibly high, incredibly quickly. That's why in ordinary English we use the term growing exponentially to refer to something that's going out of control. People use that term to refer to more than things that are technically obeying this pattern. I'm just using that to illustrate why you should expect that this gets incredibly steep incredibly quickly. Also trying to draw an asymptote here for the red one. Also gets incredibly steep incredibly quickly. And finally the blue one. Incredibly steep incredibly quickly as you move out to the left. It also has an asymptote of y equals 0. It's just this time it's out to the right. So that's your exponential graph. Now, for year 12 students, they need to know this is not GCSE and it's not anything younger than that. This is y equals log ax. What this does is it has an asymptote of x equals 0, in other words the y-axis. It always goes through 1, it's kind of like the equivalent of this. If it always has a y-coordinate of y-intercept of 1, this will always have an x-intercept of 1. And it has a key point of, it's got two key points, this one. Out at A has a y-coordinate of 1. So that's A comma 1 there. So that's the logarithm graph, that's called. Again, it's crucial to show that intercept there. What else have we got? For year 12 students and AdMath students, this is also an instant graph. That's the equation of a circle. When it's the sum of two squares equal to something, that's a circle, and the reason why it's instant is because the centre just comes from comparing to this. You just decide what's playing the role of A, what's playing the role of B. So A is 3, B is -4. So A comma B, in other words 3 comma -4. That's the centre. So this key point is not a point on the graph, it's the centre. And the radius comes from comparing this to this. So my radius is 3. So you go up 1, you get to 3 comma -1. Go over here, get to 0 comma -4. Go down, you get to 3 comma -7. Go across, you get to 6 comma -4, and those are your 4 key points that are on there. And then you connect them. That's the equation of a circle, which you try to do a bit more neatly than that. Now, what else? If you have not all this squared business, but a square root, as long as the x squared is after the subtraction, then this is a semicircle. Semicircle centered at the origin. And it's really easy to work out how big you should make it. Just do a y-intercept. If x equals 0, then y equals the square root of 9. So there we go, you're done. So that's a semicircle. You don't need that for GCSE. That is for Add Maths and Year 12 and 13. What else have we got? There's y equals sine x. I call this the Loch Ness Monster. Does something interesting every 90 degrees. By interesting I mean move from, so imagine this is like the sea level of Loch Ness. So something interesting either means coming out of the sea and reaching a peak, that's something else interesting, returning to the sea, going deeply under the ocean and then back to the surface. Goes out on the left as well, and it gets as high as 1 and as low as -1. And it goes on forever in either direction. So that's y equals sine x. Y equals cos x I'll do in red. It's the same thing, but this time the central hump is dead center. Same thing. Every 90 degrees it either reaches its minimum, reaches a maximum, or crosses the axis. So it's your cos x graph. Now year 12s and 13s know that there's an alternative measure of radians, of angles, which is these. And that enables you to draw this properly with a scale where the horizontal axis matches the vertical axis, because pi over 2 is about 1.5. So if that was 1 and I wanted to make the scale on that vertical axis and the horizontal axis the same, I'd probably want to put that pi over 2 a bit further over there, but that's not really a big issue and it's certainly not relevant for GCSE students. And your final instant graph is y equals tan x. Again, this does something interesting every 90 degrees. This time interesting means either crossing, which it does there, or reaching a vertical asymptote. So, draw this in black. So it's like the cubic, but it's not flat at the central turn. So this is tan x I'm drawing now. Goes on forever, it's got all these asymptotes. Sorry, that's pretty sloppy. And it has a gradient of 1 there. So that the y equals x would be a tangent to the graph there. So it's pretty sloppy, I should have made that a bit steeper. But of course y equals x would only fit on this graph if you're measuring in radians. So since I've used degrees there, I shouldn't be ashamed of how poorly I've indicated the gradient of that. So they are your instant graphs.